Okay. Worksheet 3. When we solve an algebraic expression like 2x plus 5 equals 9, how many answers do we get? 2x plus 5 equals 9. We get one solution. If we were to graph in y1 and y2, 2x plus 5 would look like this, y equals 9 would look like this, and they would cross exactly one place, right? Okay. Now, when we do trig equations, if I have this graph, ooh, I didn't draw that too badly, and I want to know how often it hits, say, 0.2, it hits it over and over and over and over and over, right? Yeah, but they occur on a regular interval. So we have to find this one and then this one and say it's going to repeat every like 2 pi if it's a cosine graph or sine. Okay, so let's talk about it in terms of this equation right here. You got your unit circle out? Okay, where is the cosine 1/2? On your unit circle, the cosine is 1/2 at pi over 3 and 5 pi over 3. Now, I'm going to change and talk about that in degrees for just a second because we all think in degrees, right? So it's 60 and 300, yes? Okay. Coterminal means you do what? Add or subtract 360 if you're in degrees or 2 pi if you're in radians. Now, remember, if I add 360 to this, I get 420. If I type the cosine of 420 in my calculator in degree mode, am I going to get 1/2? Try it. Put your calculator in degrees, type cosine of 420. Okay. If I add another 360, I'd have 780. Try cosine of 780. Okay. If I did 300, if I added 360 to that, I'd have 660. Are those all the same value? Okay. It goes on forever because every time I add or subtract another period onto it, it's going to repeat and it's going to have the same answer. So if we want to find all solutions everywhere in the whole wide world that the cosine is 1/2 in radians, we're going to have to list these. We found this solution right here where they intersected and this solution. And those were all before 2 pi. And then we're going to say, and this one will repeat 2 pi later, yes? And this one will repeat 2 pi later. So we're going to put plus or minus 2 pi n, plus or minus 2 pi n. I scribbled that in there really tiny. So pi over 3 plus or minus 2 pi n, where n is any integer. Yep, integ, because that's all I can fit on the screen. All right, 5 pi over 3 plus or minus 2 pi n. Now, there's actually a shorter way to write that one. I'm not going to spend a lot of time worrying about the shorter way to write stuff. It's a good brain teaser. Okay? But cosine has y-axis symmetry, yes? So I could go pi over 3 this way or pi over 3 this way, and I'd still hit that same value. So I could say pi over 3 positive or negative would give me an answer, and then every 2 pi n after that. So that's the shorthand version because cosine is symmetric to the y-axis. But I'm fine with the longhand version, okay? Just like when we wrote sine and cosine graph, we took the graph and we wrote an equation. Remember I said you could use a positive cosine, you could use a negative cosine with a shift. There's a lot of answers, okay? All right. When they say on this interval, then we're going to have to write it like this. They say all answers, we're going to have to write it like this. If we go back here to my disaster, If it had said down here, see how it said just 0? Let me get a highlighter or something here. See down here what it says, if you want only the answers between 0 and 2 pi, when we get to those problems, you're going to go, woohoo, because you don't have to put any plus or minus on the back. Between 0 and 2 pi, the only places are at pi over 3 and 5 pi over 3, right? If you have a restricted area to look at, then you're in good shape. All right, so we're going to solve algebraic or trigonometric equations today. This is a really important lesson because it's one of, you didn't do this at all in Honors Algebra 2 or Algebra 2. If you took the full trig course, you maybe did a little bit of it, but we're going to do a lot of it in here, okay? Solving trig equations. It's one of the big things we hit on that isn't really taught anywhere else that prepares you for calc. Okay, we're going to use a lot of algebraic techniques. You can square root both sides. You can square both sides. You can factor and take your turn being equal to 0. You can add and subtract things to the same side, all kinds of stuff. All right, it does say quadratic formula here, and I didn't see anywhere we had to use quadratic formula. So the other thing is we might need some trig trades. All right. In other words, if an equation has both a cosine squared and a sine squared, we might have to trade one of those out so that everything is in terms of cosine or sine. All right, I have this question is really kind of icky, and it's all worked out on your paper, so I just need eyeballs up here, okay? Don't have to do this. Don't have to write anything down. This says tangent times cosine minus cosine. Can I just subtract off the cosine and write tangent? Yeah, not so much. I can factor out a what, though? Cosine. If I divide the cosine out of this one, it'll just say tangent, yes? If I divide the cosine by cosine, I get... Is everybody clear that that's the only way that it would factor back to that or distribute back to that? All right. Then we get to play Hofbauer's favorite game. If this times this equals 0, then we get to take your turn being equal to 0, right? One or the other of them has to equal 0. So the cosine is 0 or the tangent is 1. Okay, unit circle in hand. Where is the cosine 0? And it says between 0 and pi over 2. So we only have to look on our unit circle. We don't have to add any plus or minuses. Is at pi over 2 and 3 pi over 2, right? Has a cosine value of 0 or an x coordinate of 0. Tangent is not on your unit circle. How do you find tangent? You have to take the y and put it over the x. But if the y and x are going to become 1, they have to be something maybe like this. So when you put that over that, you get 1. Why is it 5 pi over 4? Because 2 negatives make positive. We okay? Now, this is a miserable question, and I do hereby solemnly swear I will not ask this question because we have to throw 2 of these answers away. If I were to put back in pi over 2, what is the tangent at pi over 2? Undefined. So if I put it back in, it would say undefined times 0 minus 0 equals 0. And unfortunately, we don't have anything that says undefined times 0 is really 0. So this one, if you look at your paper, it says you got to throw these away because tangent's undefined. I'm not going to ask one like that, okay? Because I would have got it wrong. I will tell you the way to check these. Let me show you real quick. Can someone read me the original question here? 1 second. Woo! What am I doing? Down, 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 clear. Okay, the original equation said tangent times cosine of x minus cosine of x, okay? I very carefully set my window to be exactly 0 to 2 pi. Do you see that? Because that's what they wanted, okay, was 0 to 2 pi was the interval. Then I graph. If I want to see how many times it hits 0, will that tell me how many solutions this should have? Okay. And you notice it hits 0 how many times? 2. So I knew there was a problem because I got 4 solutions, okay? So that would be the way to check if you have extra solutions or not. All right, I'm going to talk about this one super fast. You don't have it. If I were doing that question, I would subtract 1 from both sides, algebra. I'd have 4 sine squared equals 3. I divide by the 4. Sine squared equals 3/4. Square root both sides. What happens when you square root an x? You got to remember plus or minus. Okay, square root of 3 is square root of 3, but square root of 4 in the denominator is plain old 2. Is that on my unit circle? How many places? If it's plus or minus, it's 4 places, yes? Okay, so you'd have 4 answers, and if it just said 0 to 2 pi, you'd have just the 4 answers. Okay, when it says all solutions, the bottom line is every time it's a sine or cosine question, it's going to repeat every how often? 2 pi. So you're going to have to put on a plus or minus 2 pi. The book says just use plus 2 pi, which I'm fine with. Because remember, n is any integer, and integers can be positive or negative. Okay, I always write plus or minus, so I'm sorry. If it's a tangent question, it repeats every pi. Okay, so you could just put it down once and then say it's going to repeat pi later. All right. Here's this one. Again, you have this already written out. If you don't want to do it with me, it's fine. What will we do first, though? Algebraically. Yeah, it doesn't really matter which way we go. Okay, if we add a sine x over here, 2 sine x plus square root of 3 equals 0. Sine x equals negative square root of 3 over 2. I skipped a couple steps there. Are we all right? Okay. Where does that happen on my unit circle? Thinking I got to go back here because it said what? All solutions. So 5 pi over 3 and okay. And because it says all solutions and it's a sine graph, it's going to repeat every 2 pi. Are we okay with that part? Okay. Not really a shorter way to write that one. All right. Easy peasy. We can do this. This is an easy one. Where's the cosine -1? Nothing to do. Just pick up the unit circle, look, and tell me pi. Is that the only place? Okay. If we had graphed a cosine, it would hit -1 at pi, and then not again until 3 pi, right? 2 pi would be in here. Is everybody seeing how that's working? How did I know to put the plus or minus on the back? Because it said all, and a lot of times it will also say all from -infinity to infinity, okay? All right. This is just a really quick, when we would have questions like this, you all eventually learned to just take out the x and get 0 or 2, right? But at one point back in the day, when you saw this kind of question, you tried to divide by x. And when you did that, you got x equals 2. You lost a solution, right? Okay. So be careful. You want to move everything over and factor, not divide things out, okay? Do not divide out cosine or sine functions. All right. With that in mind, we don't want to divide out a sine. What do we want to do? Factor out a sine. When I factor out a sine, what will I have? Are those both perfect squares still? Yeah, you can skip if you forget to write the x down. I'm not going to take it off points. Okay, time for my favorite game. Sine of x could be 0. Sine of x minus 2 could be 0, which would mean the sine of x was 2. Sine of x plus 2 equals 0, which would mean the sine of x is negative 2. Now my really favorite part of this question is we have garbage, garbage, and garbage, right? Okay, but can the sine graph, does it ever hit 2? So we did all that work to find out the sine has to be 0, which happens at 0 and pi. Now it says all solutions, so we got to throw a... Now, there is a shorter way to write that one. Okay, does Miranda's answer work? If you start at 0 and you go pi, and then you go pi again, and then you go pi again, we hit all the places that it's happening? Yes. I'm perfectly fine with this answer. Okay. Some of you like a little puzzle. How short can I write this? But it's okay to give me the other one. All right, what can we do here? This is sine times cosine minus 3 times cosine. So if we take out a cosine, what will it say? Okay, take your turn being equal to 0. We have cosine is 0, or the sine is 3, which is garbage. Careful. Plus or minus. Yep, how could we write that? This is fine. Or, this is fine, but aren't those straight across from each other? So we could say pi over 2 plus or minus pi n, but yeah. I don't, I'm fine. You don't have to get all fancy with me, okay? You can type in your calculator, but the sine graph goes only between 1 and negative 1. That make sense? Okay. Nowhere on your unit circle does it say the sine is more than 1. Yes. Yes. No, it would not have been wrong. That's a great question. Some people want to, instead of 0, put 2 pi, because it's the same place on your unit circle, right? I don't care. I'm not going to count that wrong. All right. What are we going to do here? We're not going to do what? Don't divide. We got to move it over. Okay, work on this one, guys. Factor it out, see what you get. Can't refactor that one, so you're going to have to square root. What happens when you square root? Plus or minus, right? Square root of 1 is 1. Square root of 2 is just square root of 2. If we rationalize that, we get this, and that looks really familiar on the unit circle, right? Okay, so those are the two things I got. Have I solved for x yet, though? No, I'm feeling really good about myself, but I haven't even solved for x. All I've done is find out what the sine has to equal. All right, x equals, where is the sine 0? Okay, or 0 and pi, either one is fine. And over here, where is the sign? Positive square root of 2 over 2 or negative square root of 2 over 2? Yes. This happens at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And it would repeat every 2 pi n. Now, way shorter ways to write that. Anybody figure out a really short way to write it? How far do you actually go? Once you hit the first one, how far is it to the next one? A quarter of the circle, which is... That's the shortest way to write that. If you were thinking in degrees, it'd be 45, and then you go another 90, then you go another 90, then you go another 90. Okay. But you can write it the long way. I have no problem with it. Ooh, got a little carried away there. Okay. Woo! So the long way would be all 4 of those and those 2. Otherwise, the short way would be 0 plus or minus pi n and pi over 4 plus or minus pi. Okay, miserable, moving on. I'm thinking for that kind of question, it would have been really nice if it just said between 0 and 2 pi, right? That would be bad enough because you'd have multiple solutions. We get to switch over to that now. Here's between 0 and 2 pi. Does that make things better or worse? In my mind, it makes things better because we get to look at our unit circle and be done. We don't have to put any plus or minus garbage on the back. Okay? So, where is the cosine of x equal to what? 1/2. Happens exactly where? The cosine is 1/2 means x is 1/2 is pi over 3 and 5 pi over 3. We okay? Tyson, are you looking at your unit circle so you know where we're getting these? Okay. I'm just worried that you just think I'm pulling numbers out of thin air. It's that pre-calc magic again. Okay. How about some simplifying? 5 minus 7 is what? Plus 2 sine x. So if I add 2 over there, you actually can divide this one out. If you took a 2 out back here, you'd have sine x minus 1, and 2 can never equal 0, so you'd still just get this, okay? Doesn't matter. All right, so where's the sine 1? Only at pi over 2, right? And then it repeats every... Oh, we don't need to repeat. Woo-hoo-hoo-hoo. I was going to get it wrong. Just said between 0 and 2 pi, so we're done. All right, what do you want to try here? We get it all to one side. What can we do then? And left will be 4 sine squared minus 1, which this factors again because 4 and sine squared and 1 are all perfect squares. 2 sine minus 1 and 2 sine plus 1. Okay, we having fun yet? The tangent can equal, the sine can equal 1/2. Is everybody okay if I don't write that all out? 2 sine x minus 1 equals 0. Add 1, divide by 2. And then the sine can also equal negative 1/2. Okay. All right. It's a nice one because it's an interval question. That's the good news. Where is the tangent exactly 0? Tangent is y over x. pi 0 2 pi. Okay, great question. Yep. Do you see? I'm going to write it real big here, but do you remember what this means? We have to include 0, but we are not to include 2 pi. In other words, I only want one answer for the same spot, okay? And they want us to use 0. So this is 0 and pi, yes? Because 0 over 1 and 0 over -1 would be 0. Tangent is y over x. Okay, where's the sine 1/2? And -1/2? Six answers. How could we double check to make sure there was supposed to be 6 answers? Could graph it. It's right. Take my word for it, okay? Are we good? Oh, easy one. You guys do this one. 2 answers. Why is there only 2 answers? It's positive, and because they limited us to 0 to 2 pi, right? Did I do it right in my head? Make sure I get the right quadrants. You good, Jared? All right. Ugh, this is a miserable one. You guys take a break. Put your pencil down. Okay. I can move everything over here, so I have a 2 tangent squared. I could add this 2 tangent over to that side. I have a plus 2 tangent. I could subtract this 1. I have a plus 2. But I still have what? Minus secant squared. That was lovely. What can we do? I don't think we want to factor this because we have 4 terms. What? Okay. Grouping isn't going to help. We could move it to the other side. It's still not going to factor or do anything fun. We have to do a trade, guys. Secant squared is... Oh, would that be better if that was a 1 plus tangent squared? Because we wouldn't have any secants anywhere, then we'd only have tangents, right? Okay. So we're going to replace this. I have a 2 tangent squared plus a 2 tangent. I didn't do it in the same order that your worksheet does, by the way. And is it what's 1 plus tangent squared? Is the trade, and when I distribute it, it will become a minus tangent squared, right? Okay, 2 tangent squared minus a tangent squared back here is just 1 tangent squared. Then I have a 2 tangent. And 2 minus 1 is a plus 1. Now, some of you get really stuck on this factoring business. Just say to yourself, oh, that's a b. I don't know, I'm just picking a letter. B squared plus 2b plus 1. Tangent squared plus 2 tangent plus 1. How would that factor? Are we okay? Can we factor that? Okay. So the only time it's true that it equals 0 is if the tangent is -1. Okay, remember tangent's not on your unit circle. What ordered pairs would cause me to get a -1 when I put the y over the x? √2 and √2, but I need one to be negative, right? So those two spots, tell me again. Do I have to put any plus or minuses on? All right. And that was the answer they got? Yes. From my misery. Okay. Oh, there's another one? Okay. Now this is actually an important one. Is there a trade for cosine that will get us sine or sine that will get us cosine? A squared, but not a plain old one, right? So guess what we have to do to both sides? Square them. Okay. What is a 1 plus cosine times a 1 plus cosine? Oh, I just lost an x. Is that okay? 1 plus 2 cosine plus a cosine squared equals, what's over here? Okay. Oh, that's much nicer. I don't, well, if we divide, I got rid of sine squared, but you could do it a whole bunch of different ways. How could you replace this with a what? 1 minus cosine squared? It doesn't matter. You could do it differently. But since I already had this plain old cosine over here, I got rid of sine. Okay. Now there's an equal in here. Oh, look what happens. If I subtract 1 off each side, that's gone, right? If I add this cosine squared over here, what do I have? So I have a 2 cosine plus 2 cosine squareds. So I can take out a 2 and a cosine. What will be left? Be careful. Okay. Does 2 ever equal 0? Does the cosine equal 0? At what places? Okay. Does the cosine ever equal -1? Okay. If we wanted to graph this and check, you would want to graph the original equation, which was what? Okay. If I graph that in y1 and y2, what am I actually looking for? Intersection points. Good call. 1 plus cosine and sine. 0 to 2 pi. I'm looking for intersection points. How many intersection points are we seeing? 2. 1 here and 1 here. What did we get? Got 3. Okay. When you square both sides is a prime time to get a solution that doesn't work. Okay? When you square both sides, it's a problem. I want you to help me put these in. 1 plus pi cosine pi over 2 equals sine pi over 2. Look at your unit circle real quick. What is the cosine at pi over 2? Sine at pi over 2. Does that one work? Okay. If I put 3 pi over 2, it would say 1 plus the cosine at 3 pi over 2 equals the sine at 3 pi over 2. That would be 1 plus equals -1. Okay, 1 plus the cosine of pi equals the sine at pi. 1 plus -1 equals 0. That one works. We had to throw that one away. Okay, when you square both sides is a good time to look if something extra has shown up. Probably not going to put that on a test quiz. All right, what can we do here? Uh-oh, we're back to all solutions. If you want a square root, you can, but you got to remember what? Plus or minus. Okay. You could subtract and then you would factor and you'd get plus and minus. Same thing. Where's the tangent 1? Pi, it's positive 1 at pi over 4 and 5 pi over 4. It's negative at 3 pi and 7 pi over 4. But really, how often does tangent repeat anyway? Every pi. So we could just pick one positive 1 and one negative 1. So you could shorten it to that. Or you could put a plus or minus 2 pi n on all of them. I'm not going to count it wrong, but since the period is really pi, this actually would be the shortest way, I'm thinking, to write that. Because think about where your answers were. Here, 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 and here, right? Yes? So I could go this way 45 or this way 45, and I'd hit an answer. And then I could go straight across from there, and I'd hit another answer, yes? You could put a plus or minus pi over 2, because it is actually every 90. Okay, moving on. What do you want to try here? We need a trade. Subtract the 1. There's no trade for cosine, but is there a trade for sine squared? Would that be a better thing to have? Why would that be better? Because we now only have cosines. Okay, do some algebra. Now, this is not the order most of you like to factor in, but it does factor. If I put 1 minus cosine of x minus 2 cosine squared of x, or would you rather I moved it all to the other side? Yeah, we could multiply by a -1 or move it all to the other side. Some of you would feel better. 2 cosine squared plus the cosine minus 1. You don't have to, but some of you would look at that and factor it more easily, yes? So again, if I replace it with a b, it's 2b squared plus b minus 1. How does that factor? 2b and b. Yeah, 2b minus 1 and b plus 1. 2 cosine x minus 1 and cosine x plus 1. So what does the cosine have to equal? Is this all solutions still, or only 0 to 2 pi? All? Darn it. Okay. 1/2 pi over 3 and plus or minus 2 pi n. And cosine is -1 pi. Okay. I believe they all work. All right. We will try to finish up the rest tomorrow, and we're going to do another worksheet of practice, but you can get started on 331 if you have time, because tomorrow there is a homework check due, right? that we started working on last Wednesday. So I hope to get some of them turned in.